Number 1, k plus 12 equals 336. What is the solution to the given equation? So when we have an equation in algebra, to keep things equal in our equation, anything we do to the left, we have to do to the right. So to get k by itself, I need to get rid of this 12 that's being added. I need to undo that, but I need to do it to both sides. So I'm going to do the opposite of adding 12. I'm going to subtract 12 on both sides. Those cancel out on the left, leaving just k. Let's get a different color. That's not a great. Let's make this nice and there we go. Hopefully that's more visible. Okay, and on the right, 336 minus 12 is going to be 324. And if we look over at our answers, that is choice B, which is our answer. Number 2, the function f is defined by f of x equals x cubed plus 15. What is the value of f of 2? Anytime we have a function that's in this form of f of x equals something, what it means is whatever's over here, if I pick a number, I plug it in wherever there's an x in this equation, and then we want to see what the output is. So whatever's in this parentheses is what we stick in every time there's an x, and then f of x would be the output. What answer do we get after we do all that math? So in this case, our function, our f of x, is x cubed plus 15. So whatever number would be presented here, we would need to plug in everywhere there's an x. And they're asking us what is f of 2. So I need to take 2, since it's f of 2, and plug it in wherever there's an x. There's only one x here, so I'm going to change that x. Plug in my 2. 2 cubed is 2 times 2 times 2. 2 times itself 3 times. 2 times 2 times 2 is 8. And then it says next to add 15. So 8 plus 15 is 23. And that is C. C is my answer. Number 3. Sean rents a tent at a cost of $11 per day plus a one-time insurance fee of $10. Which equation represents the total cost, C, in dollars to rent the tent with insurance for D days? Okay, so think about this as saying $11 per day. So every single day, he's going to pay $11. If this were 5 days, he'd pay $11 the first day, $11 the second day, $11 the third day, $11 the fourth day, $11 the fifth day. He would pay $11 5 times. Or 11 times 5. So for 5 days, it's 11 times 5. That insurance fee of $10 is a one-time fee. He only pays that once. So if it were 5 days, I would say it's 11 times 5, and then I would add on that $10 that I paid for that one-time insurance fee. But here we're not being asked a specific number of days. We're being asked for a general rule. D days. We don't know how many days it would be, but we want something that will work no matter what we plug in for D. So what did we do here? When it was 5 days, we said 11 times 5, the number of days, and then we added that one-time insurance. So what if it was, random ruler out of nowhere. What if it was D days? It's the same thing. It would be 11 times D, that number of days, plus 10. When we have these right next to each other, we don't have to put the little dot or a multiplication. We can just combine them and say 11D plus 10. And let's look up here. Let me zoom in a little more so you can see their choices a little more clearly. Oh, and there it is. C is equal to 11D plus 10. C is my answer. Right. Number 4. Note the figure is not drawn to scale. When they tell us this, they're letting us know that this is the general idea of what it is, and it's pretty accurate, but you will not be able to solve this by trying to measure things. And saying, oh, I can measure this, and then that will, no, it's not drawn to scale. Don't try to measure it. You're going to have to do math, not just eyeball it. In the figure shown, line M is parallel to line N. What is the value of X? When we have two parallel lines, and then we have a line across them, which is called a transversal. You're going to hear that a lot. there's a whole bunch of theorems and relationships between all the angles that are formed. In sort of broad general terms, I'll put links to videos down below that explain why all this is true. But just for this, I'm just going to tell you what's true. All those that I just highlighted in orange, the orange highlight, all those angles are the same. And all these angles that I'm highlighting in blue are the same. That's the whole thing. Now, if you go into your geometry textbook, there are going to be a ton of different ways of describing this relationships. They might say things like, alternating interior angles are congruent. Alternating exterior angles are congruent. Same side interior angles are supplementary. There's so many combinations of this, but this little chart right here is the overall relationship. That's all the angles and the ones that are the same as each other. Now, as you can see, like here, you see these two are forming a line together. And whenever we have, and right there, these are forming a line together. They're all over the place. They're forming lines together. Anytime we have two angles that form a line together, they are supplementary. They add up to 180 degrees. So if I'm looking at this, you can say as a general rule, if we're talking about the orange and the blue angles in this picture, the orange angles and the blue angles are supplementary. They add up to 180 degrees. And now if I were to rotate this 90 degrees, I would have, color code this the same way, I would have this same diagram over here. And I'm going to highlight it the same way. The blues, all those blues there are going to be the same. And all these oranges are going to be the same. There we go. And as we said, because this is forming a line, that's going to be 180 degrees. The blues and the oranges together are going to be supplementary. So this is a blue, and this is an orange. And again, I'm not using blue and orange in the sense of, like, this is a rule in your book that they're going to say blue angles and orange angles. I'm only saying it in the sense of those are the colors I chose for my diagram of blue and orange. But just to show you the relationship of which angles are the same. So I have this one and this one, which according to my little chart, these are supplementary. The rule you're going to see in your geometry book for this particular relationship is same side interior angles are supplementary. And they mean the same side of the transversal, and interior meaning they're in here in the interior of the parallel lines. Okay, since they add up to 180 degrees, I know this one is 26 and this one is X. So I'm going to say, I'm going to zoom out just a little bit, move up. Okay, so that X angle plus that 26 degree angle equals 180 degrees. Now to solve for X, I need to undo what's been done to it. 26 is being added. I need to subtract 26 from both sides. So on the left, that X is left by itself, and on the right, I have 154. So X is equal to 154 degrees, and that is D. There's my answer. Number 5, John paid a total of $165 for a microscope by making a down payment of $37 plus P monthly payments of $16 each. Which of the following equations represents this situation? Okay, so he has to pay off the whole microscope. At the end, he has to pay $165. How does he pay that? Well, first he pays them $37, and that's a down payment. And then every month, but we don't know how many months, we're just told it's P months, this unknown number P, he paid $16 every month. Well, if I paid $16 for 4 months, how would I find out what's the total amount I paid? I would say 16 times 4. If I paid $16 for 7 months, my total would be 16 times 7. If I did it for 10 months, it would be 16 times 10. So I'm multiplying by the number of months, how many payments I made. In this case, they're telling us that's represented by P. So that first initial down payment of $37, and then he also, we're adding here, $16 times however many months. Now, normally when we have equations, we would put our variable first. So let's do that. I'm going to write it as 16p plus 37 equals 165. And if I look at my choices, sure enough, there it is. C is my answer. Number 6. If y equals 5x plus 10, what is the value of y when x equals 8? So they want us to plug in 8 for x and then do the math. So we have 1x right here. If there had been more than 1x, I would have plugged in an 8 for every x. But here there's only 1x, so I only have to do it once. I'm going to plug in that 8 for x. 5 times 8 is 40. I need to add 10, and that gives me 50. So when x is 8, y is equal to 50. 50 is my answer. Number 7, we have a graph here. The bar graph shows the distribution of 419 cans collected by 10 different groups for a food drive. How many cans were collected by group number 6? So there's no math here. They're just testing your, when I say math, like no calculations here. They are just testing your ability to read a bar graph. Now, one of the big things, it is not present in this graph. I want to be clear on that. But also be aware of this, because when you're taking the actual SAT, they may present a problem similar to this, but it may have this element is look at the scale on the sides, look at all of your labels, and make sure that this is not saying like this is number of cans where each one of these spots represents like times 10, like you need to multiply by 10 to find out how many cans. Again, that is not present here, but it's something that they like to do, and you might see that on the actual SAT. So please be mindful, be careful that you know what exactly these numbers on the side are representing. So here it's just straightforward. This one's very straightforward. So when it says number of cans, so this 10 means just that, 10 cans. We don't have to multiply by 5, by 10, by 100. It's just 1 to 1. And that's great. Again, just be aware. So how many cans were collected by group 6? Down here we have our groups. So I'm going to look for group 6. I'm going to go see how far up it goes. It is touching this line. If I go over here, that is right at 40. And it's dead on. There's no gap. It's not above, it's not below it. That is straight. It is 40. So that is my answer. 40 cans were collected by group 6. Number 8, the table gives the distribution of votes for a new school mascot and grade level for 80 students. If one of these students is selected at random, what is the probability of selecting a student whose vote for new mascot was for a lion? So anytime you're doing this where you're saying, what's the odds of this portion of the whole group? What are the odds of getting this one little person from this subgroup if I'm pulling a name at random? We want to be thinking about this in terms of part to whole. So in this case, it would be this subgroup. The part would be they voted for the mascot to be a lion. And the whole would be all students. And that's going to give us our ratio here. Because out of all the students, I pull a name out. What are the odds that that student voted for it to be a lion? So the whole number, the total number of students, if we look here in our chart, these are your totals. And they're telling you the totals in each grade level and then the sum, all total students. This total column right here is telling you the total of the votes for each mascot all the way down and the total number of votes. And it's going to be the same because just depends on how I'm looking at this group. I can either look at them as students in a grade level, or I can look at them as students that voted for things. Either way, there were 80 students participating. So my whole here, my number of students is going to be 80. Then we say, okay, what's the part? The part is those who voted for a lion. It doesn't matter what grade they're in. It just said the ones that voted for a lion. So it's this row right here. And the total number of students who voted for a lion was 20. So that's our part. That would be 20. But as you may notice, 20 over 80 is not an option in these choices. So we need to simplify this. Anytime that I have a fraction where there are at least one zero on the end of top and bottom, you can cross those out 1 to 1. So like if this was 200, 800, I could cross out. If this was 208,000, you can only cross out the smaller number. Boom, boom. It'd be 2 over 80. That's just a little side note math trick. If you didn't know that already, it's, it can be a little helpful thing. All right, but we've got 20 over 80, so I can do that first. Boom, 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 boom. 1 0 on top and 1 0 on the bottom. That leaves me 2/8. And are there any numbers, any greatest common factors of 2 and 8? Yes, there are. 2 goes into both of them. 2 goes into 2 one time. 2 goes into 8 4 times. So 2/8 is the same as 1/4. Or 20/80 is the same as 2/8, which is the same as 1/4, which means C, 1/4 is my answer. Number 9. The graph represents the total charge in dollars by an electrician for X hours of work. Okay, so on my X graph down here, so this is hours of work. And it's the total charge in dollars. So dollars is going up this way. All right, the electrician charges a one-time fee plus an hourly rate, okay? What is the best interpretation of the slope of the graph? So if he has a one-time fee, let's say he just shows up at your house and then says, nope, I can't work on this, and leaves. We're going to assume that this still would incur the one-time fee. So he didn't work for any hours at all, but he still charges you the fee. So at 0 hours, let's say he charges $10 just for showing up. So if the hourly rate would be 0, this is my hourly rate right here, my hours worked. When X is 0, there would be my $10, my fee. So that's what this point represents right here. That's the one-time fee, because it's not down here at 0. He starts off before he does any work at all with the one-time fee. And we don't know what exactly this is. I'm just using 10 as an example. So let's say what happens when he works 1 hour. Well, then, let's say maybe that's around right here. Well, now it's up to here. What if it's 2 hours? Well, now it's up to here. It's 3 hours. Now it's up to here. But this is this is linear. It's going up by the same amount each time. And we don't know exactly what this is, but we can, let's say if we guess and say, all right, this is going up. How far up did this go? Maybe it goes up by 20. And then the next time it goes up by another 20, that this y coordinate's 20 higher. And this y coordinate is going up another 20. It's going up the same each time. Whatever that number is, it's going up the same each time. So what is that? Let's look at our options down here. Is this the electrician's hourly rate? Is it their one-time fee? Is it the maximum amount that the electrician charges? Is it the total amount that the electrician charges? Now, based on what we just said, hopefully you're kind of zooming in here and saying, I think it's the hourly rate. And that is the correct answer, because as his hours go up, his amount charged goes up, and it goes up at the same pace. So that is his hourly rate going up. It's increasing steadily, linearly. Okay, so A is our answer, but let's look at the other three just to really confirm why this is the answer. B, the electrician's one-time fee, as we established, no. This right here, the y-intercept being a little higher, that's representing his one-time fee. When he hasn't worked any hours at all yet, but he's still starting out with a little money, that's the one-time fee. C, the maximum amount that the electrician charges. No, if we're talking about the slope of the graph, how it's going up like this, it could go on forever. It has a possibility. If he worked for you for 1,000 hours, it keeps going. So that slope is not representing the maximum amount. There technically isn't a limit to the maximum amount he could charge. The total amount that the electrician charges, that might be what this point on the line represents. This might represent the total amount he charges for so many hours of work. But again, they're asking about the slope of the graph. What does this going up here represent? This steady increase. It says hourly rate, so it's being multiplied by those hours, and that's what you're getting on these points. So A is your answer. Number 10, square x has a side length of 12 centimeters. I'm just going to draw it. I always draw immediately when they start telling me these things. All right, square x has a side length of 12 centimeters. The perimeter of square y is 2 times the perimeter of square x. Okay, so now we've got, and I'm clearly not drawing this to scale, so I'm just going to draw a vaguely larger square y. It has 2 times the perimeter of square x. What is the length in centimeters of one side of square y? When we're saying the perimeter is twice as big, be careful with this. Perimeter, area, volume. Each one of these is going to have a different relationship. Perimeter, it is 1 to 1. It's a direct relationship in that if this perimeter goes up by 2, to form this square, then that means the side also went up by a factor of 2. The perimeter is twice as long. The side is twice as long. So this is 12. 12 times 2 is 24. This is only for perimeter, not area, because with area, we're squaring things. It's an exponential. This is linear. You're saying it's a line, and the line is twice as long. Because if I took this square and I flattened, if I put like a fence around this square and then I put all the fence in a straight line, and then this one has fence around it, that line of fence is twice as long. So just doubled it. And you can kind of, I'll show you this mathematically, another way to sort of show you this. So this is 12 plus 12 plus 12 plus 12, or 12 times 4. So the perimeter of x is 48. Now I say that perimeter is, get rid of this for a second, the perimeter is twice as long, so I would multiply that perimeter by 2. Well, I need to multiply this side by 2 as well, right? So on the right, I would have 96, and just to make a point, I'm going to distribute this. Boom, boom, boom. So then that becomes 2 times 12, or 24, plus 24, plus 24, plus 24. So there, algebraically, is why that one side is 12. If the perimeter is doubled, the side is also doubled. It would be 24. So hopefully that makes it a little clearer, showing you a couple different ways to view this. Again, this is perimeter, not area. Area, because things are exponentially, you're multiplying them. It's a whole different beast. For example, like if you have 1 by 1, and then you go up by 2 by 2, that side has doubled. Has the area doubled? No. The area has gone up by a factor of 2 squared, not by a factor of 2. This one, the area is 1. This is the area is 4. That's why I'm saying be careful. In this perimeter, it's direct, but if they change it up on the day and they tell you area, don't use this. Just be careful. Make sure it's perimeter. So again, our answer there is D. It is 24, twice as long, for a twice as long perimeter. Number 11. What is the equation of the line that passes through the point 0, 5 and is parallel to the graph of y equals 7x plus 4 in the xy plane? They're testing your knowledge of the slope-intercept formula of a line, or slope-intercept equation of a line, excuse me. And they're also testing that you know the relationship of parallel lines. Perpendicular lines is something they also test on you. So I'm just going to show you both of them real quick. Parallel lines have the same slope, exactly the same slope. If they're perpendicular, this also comes up a lot. They're going to be reverse reciprocals or opposite reciprocals. So like here, this line right there, if that line has a slope of 1/3, this line also has a slope of 1/3. If this line has a slope of -2/3, this one will have a slope of +3/2. These two relationships, memorize them for this test. Very important. So for this one, it is parallel, so they're going to have the same slope. Now when we have this y equals mx plus b equation, our m is our slope, the x and the y's always just stay there, and the b is our y-intercept. So we have this equation of a line that passes through the point 0, 5. Where is 0, 5? Well, my x and my y, x comes first, so 0, and then 1, 2, 3, 4, 5. So 0, 5. That's the y-intercept. That's 5. So I know my new line, I'm starting with that y equals mx plus b. I know my b. That y-intercept is 5. Woohoo! So honestly, if you look at your answers, there's only one that has a plus 5. You've already got your answer, but let's pretend that they tried to make this, a little more interesting by giving you more than one option that had that as a y-intercept. And we're going to look at the slope because they may not be that nice on the day on your actual SAT. So we're looking at what is parallel to the graph of y equals 7x plus 4. So again, we have that y equals 7x plus 4. This m here, that number that's next to the x, that is our slope. So it's saying it has a slope of 7. And as we just discussed, lines that are parallel have the same slope. So we want our new line to also have a slope of 7. So that's going to go right here in place of this m. And so there is my final y equals 7x plus 5. But again, as I said, if you look at all these answers, there's only one that has plus 5 on it. So as soon as you figure out that the y-intercept is 5, that it's going to have a plus 5 at the end, you have your answer. That's why it's always a good idea to look at all your answers. I say even before you do the problem, just because a lot of times it gives you the answer. There's one on this test. I think it's 27 on this module. That's like that. There's 20. It's in the late 20s where it's yeah. If you just look at the answers, it kind of gives it away, even though it's a harder problem. Number 12. In the linear function h of 0 equals 41 and h of 1 equals 40. Which equation defines h? So these are functions, and when you have a function, most commonly you see as f of x equals blah, blah, blah. What it means is there's going to be x's, usually, it doesn't have to be, it could just be a number. There's probably going to be an equation here involving x's, and you're going to be given numbers and saying f of x, like f of 2, f of 3, f of 4, whatever, f of 5,272,000, who knows. But f of whatever that number is, they're telling you wherever there's an x, plug that number in, do all the math, and see what you get. And that's going to be your answer. So it might say like, oh, f of 2 equals 221. It means I took 2, I plugged it in wherever there was an x in this equation, and the answer I got after I did the math was 221. All right, so this one they're saying h of 0. So h of 0 was 41. There was an equation, they plugged in 0 wherever there was an x, and then they did the math, and they got 41. It's saying which equation defines h. So let's go through these, and let's just start with that h of 0 equals 41, and then we'll move on to the second one. So we're going to do each one of these in turn and see what we find out. First one, negative x plus 41. Wherever there's an x, we plug in 0. So negative 0, negative 0 is just 0. Plus 41, that equals 41. Okay, we're told it would equal 41. That's true. All right, so A is an option. Let's try B. H of x equals negative x. So I'm going to plug in a 0 wherever there's an x. So a negative 0 is just 0. And that's it. Did I get 41? No, I didn't. I got 0. So B is out. That is not an option. Eraser, there we go. Then we have C, negative 41 times x. Again, I'm going to put 0 wherever there's an x. For negative 41 times 0 is 0. I did the math, I got 0. I did not get 41, so C is out. Okay, rid of that. And last but certainly not least, h of x equals negative 41. When you see there are no x's there, it just means whatever number you put in, it's going to be negative 41. So if I plug 0 in, I'm going to get negative 41. Is that 41? No, it isn't. So D is out. I don't even have to do anything else. I'm going to, just to prove it to myself to make sure. But yeah, you already know A is your answer. Personally, I think that's a little sloppy on the SAT board's part. It's unlikely, I'm going to say, that you're going to get something like this on the day. Most likely, you're going to have like an A, B, C, and D in this kind of thing. And usually what happens is that at least two of them would fit the first one. Like say maybe A and C, for example, would fit the first one. And then you'd have to test to see which one of those would fit the second one. I'm not really sure why they did it where you just have to do the first one, the H of 0, and you automatically have your answer. Frankly, if I was taking the test on the day and I saw this, I would be suspicious and think I had done something wrong, because it's just really weird that they all get eliminated by the first equation. But that is what's happening here. But let's just double check our answer to make sure. H of 1 equals 40. So negative x plus 41. If I plug in 1 wherever there's an x, I get negative 1 plus 41, which is 40. Yeah, that is correct for both of those. A is my answer. Number 13, the function f of t equals 60,000 times 2 to the power of t, or 410, gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? When we have this kind of exponential growth, this number that's out here in front that is being multiplied by this number with the exponential, this first number here, that is our origin. That is the initial observation in this case. It is the initial number of bacteria when we're talking about this problem. It's the starting point. So I have that 60,000. That is the number of bacteria I started with. And then this right here is telling us the rate of growth. And it's t minutes after an initial observation. It tells us how many bacteria there are. So we want this to be doubled. How long does it take for it to double? When we say double, what are we doing if we're multiplying? If I said I started with 10 bacteria and it doubled, I would have multiplied by 2, right? And we've gotten to 20 bacteria. So I want to be taking this initial number of 60,000 bacteria and be multiplying by 2. So what they're asking really is, what number could I put in for t so that after I do this math, I just get 2? Well, 2 to the power of what equals 2? I'm not multiplying it by itself any times. Is that 2 to the power of 0? No, 2 to the power of 0 is just 1. But if it's 2 to the power of 1, that's 2 times itself no times. It's that same number. 2 to the power of 1 would be just 2. So I want t divided by 410 to equal 1. So you may look at that and just kind of know without doing any additional math what that would be. If so, that's great. You can move on then. If not, you need to write this out. That's fine. Just do whatever you need to do so that you get this problem right. So t divided by 410 equals 1. To solve this algebraically, t is being divided by 410. So I'm going to multiply by 410. So on the left, those 410s cancel out, and I'm just left with t. And on the right, and I missed that 410 there, sorry. On the right, I have 1 times 410, or 410. And if I look up here and say, does that work? Let me plug 410 in for t. 410 divided by 410, any number, not talking about 0, any integer there besides 0, any number, any real number besides 0. If I divide it by itself, I'm going to equal 1. So 410 divided by 410 is just 1. So 2 to the power of 1 is 2. 60,000 times 2 would be 120,000. That has doubled it. So when t is 410 minutes, is what we're talking about, 410 minutes, the bacteria population has doubled. 410 is my answer. Number 14. The function f is defined by f of x equals x minus 6 times x minus 2 times x plus 6. In the xy plane, the graph of y equals g of x is the result of translating the graph of y equals f of x up 4 units. What is the value of g of 0? There's 2 ways you can do this. The first way kind of counts on your knowledge of translating and what it does to things. Here's the basic summary. There's a lot of details that you can get, but this is the basic, the big stuff that you get tested on the SAT a lot. If I started with a function that was just say y equals, or f of x equals, let's put it as f of x equals x squared. That's going to be a parabola that looks, wow, that was awful. Let's try that. Kind of, sort of, something like this. If I wanted to translate this up by 4, what you do is you add 4 to the outside of that thing that the x is attached to, like that x squared in this case. You're adding an x4 to the outside. That's going to move it up 4. If I wanted to go down 4, it's going to send it down. And when we say send it down, let me get rid of this. I'm going to get rid of that arrow. There we go. When I say send it down, I'm talking about using the vertex as a reference point. It's sending all the points down, but the easiest is just to see where that vertex is moving to in the xy plane. So if I'm wanting to send the vertex and then by extension the whole parabola down 4, it's going to be -4. So it's exactly the same direct. If you're wanting to move it left and right, then that goes inside, not outside. So it becomes on the inside with this, and it's going to be the opposite. So if I wanted to move it to the left 4, that's toward the -4, I need to add 4 on the inside. If I wanted to move it to the right 2, towards the +2, I need to subtract 2 on the inside. That's the up, down, left, right. If I wanted to change how wide or narrow this was, then I would put numbers by it. If I put a number greater than 1, it's going to make it more narrow. If I put a number less than 1, but still positive, it's going to make it more wide. If I put a negative number out in front, it's going to flip it. Those are the big ones that you're going to see a lot. And you can combine these together. So if I had negative x plus 2 squared minus 3, that means first it's going to flip it upside down. There's my negative. This part, the +2, means it's going to move towards the negative to the left. So it's going to move over 2, 1, 2. This -3 means it's going to move down 1, 2, 3. So that is what that new one would look like. This works with functions. You can do this sort of thing. I'm telling you all this because this comes up a lot. They love things with translating. So that is good knowledge to have. It will serve you well on SAT problems. So here I have this initial x minus 6 times x minus 2 times x plus 6. Now, if I multiplied all these together, I'm not going to, but if I did, I'm going to get x cubed, blah, 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 blah. So I'm going to put that as a combined x cubed. So if I wanted to translate this up 4 units, the x and y up and down, you add to the outside. So I'm going to say plus 4. So all of this together, plus 4, it's going to move it up 4 units. So it's saying, what is the value of g of 0? So what you can do is, g of 0 is saying, and I'm going to read this one more time just to make sure we're all on the same page, because I know I've thrown a lot of information at you, but really, please remember all that stuff I told you about the translating. That's really good stuff to add to your notes to learn. It comes up again and again with these, because that's the goal with this, right? We want you to be prepared for the SAT, not just prepared for this problem, because this problem ain't going to be on there. You know what I'm saying? But the principles will be. So here in the xy plane, the graph of y equals g of x is the result of translating the graph of y equals f of x, which is this, up 4 units. So this down here is my representation, my quick representation of g of x, and this up here is f of x. So g of x, what is the value of g of 0? If I plug 0 into this, what am I going to get? And this is, again, all this represents this up here plus 4. So what I can do is I can put 0 wherever there's an x here, do this math, and then add 4, and I'll get my answer. So let's do that. First, I have 0 minus 6. Then I have 0 minus 2. Then I have 0 plus 6. 0 minus 6 is negative 6. 0 minus 2 is negative 2. 0 plus 6 is positive 6. And you can multiply these in any order you like. So negative 6 times negative 2 is positive 12. Positive 12 times 6 is positive 72. So I have 72 plus 4. That equals 76. 76 is my answer. Another way you can do this is by graphing. Now, here is, I put this into Desmos, and this is a really very tall extreme graph. So as you can see, I have really changed the proportions here. Here you see this represents 10 and this represents 50. That's just so you can see it. When you first put it in, it's going to look something like, it's going to be very like that. You really have to kind of zoom in and change the ratio, the proportions there to see it. But what you are looking for, because when it says moved up 4 units, what is the value of g of 0? So, okay, if this whole thing was moved up 4, that means every point is moved up 4. This point goes up 4. This point goes up 4. Every single point here is going to go up 4, and that gives me my new g of x. So g of 0 is if I put in 0 for x, what is my value there? So let's zoom in, and I took a second screenshot of when I really zoomed in, and I got this, that when x is 0 in my original f of x, the result is 72. And again, g of x, every point goes up by 4. So if this were to go up by 4, I would be 0.76, and that 76 is what we want. The output. If I plug 0 in for x, what do I get? I get 76. So you can do this either way. You can do it by the math of going, oh, I'm going to put 0 in for each of these 3 and then add 4, or you can graph it. Just be very clear that you understand what's happening when we say translate it up 4 units, what happens to that function, and you'll get the right answer either way of 76. Number 15, a candle is made of 17 ounces of wax. All right, so I got this candle and it's burning. Whee! Yay, candle. Okay. Like, that's not a good enough candle. Does it matter? No, it doesn't matter. But there's a part of me that's annoyed and wants it to be slightly better. There we go. All right, so a candle is made of 17 ounces of wax. That's a pretty big candle. When the candle is burning, the amount of wax in the candle, it decreases by 1 ounce every 4 hours, okay? If 6 ounces of wax remain in this candle, for how many hours has it been burning? This keyword right here, always read these problems so carefully. One little word changes everything. It says if 6 ounces of wax remain. So that's how much is left. Started with 17, it's all the way down to 6. How much burned? I guarantee you there are going to be students that see that 6 ounces and go, oh, 6 ounces have burned. Nope, it says that's how much is left. So 17 minus 6 will tell us how much is burned. 11 ounces have burned. 17 minus 6 is 11. So 11 ounces have burned, and we're told that 1 ounce burns every 4 hours. So it will be 11 times 4, or 44. Another way you can look at this, just depends on your perspective, which way is easier to kind of look at it, is as a proportion, saying it's 1 ounce every 4 hours. So if it's been 11 ounces, how many hours has that been? And as long as it's ounce to hour, we can do this. They have to be the same units. I'm telling you this because there are some problems that show up in the SAT where it's similar to this, but they change the units. So like this might be ounces per minute, and over here they want ounces per hours, and you got to make sure everything's lined up. That's absolutely same units on top, same units on bottom, and then you can cross multiply, and you get 4 times 11 is 44, and 1 times x is x. 44 is x. Both ways, you're going to get the same answer, that is 44 hours the candle has been burning, and that is D. Number 16, 14j plus 5k equals m. The given equation relates the numbers j, k, and m. Which equation correctly expresses k in terms of j and m? Anytime you see this expressing a variable in the terms of the other variable, it's very posh and very fancy, isn't it? All they're wanting you to do is not to solve. You're not going to get a number, like a solution for this variable, in this case, k. You're not going to find out that k equals 5 or something like that. No. They want you to have k equals, and they want everything else moved over onto the other side. So I'm starting with 14j plus 5k equals m, and they want everything else over here and k all by itself. Another phrasing you might see is solve for k. Solve for the indicated variable. This all means the same thing. When we say express k in terms of j and m, put k in terms of j and m, solve for k, all means the same thing, what we're about to do. All right, so I'm going to treat this like any other algebra problem, and I'm just going to undo what's been done to k to get it by itself. Here, I get rid of anything that's outside first, and then anything that's attached to it last. So outside, I have 14j being added to the 5k. So I'm going to subtract the 14j from both sides. On the left, that just leaves me with 5k now because those 14j's canceled out. And on the right, I have my m minus 14j. Then the next thing that's happened to k is it was multiplied by 5. To do the opposite of that, I need to divide by 5. So I'm going to divide this by 5. On the right, I can write it as the whole thing divided by 5, or you can also write it as both of those individually divided by 5. Looking over at my answers, I do not see anything that's like that. I see things that are over 5. I see this one, which looks like maybe it was divided by 5, it was simplified, but I have to look at it a little more closely. So I'm just going to say that since both of these are showing all of it over 5, that's what they want. That's what I'm going to assume. So I'm going to start with that. And if I don't find one that matches, I can try to get it the other way, deal with it the other way. Both are the same thing, and different problems may require you to do it either of those two ways. It's identical. So here, 5k, I divide that by 5. So on the left, I am left with k. And on the right, I have m minus 14j all over 5. And sometimes you'll be doing these problems and you'll get to a point that is a correct answer. And then you look at the options and it don't match exactly. That means you have to do some additional math to kind of transform this into one of those answers. But fortunately for you and for me, this is not one of those times. And there it is, exactly as we have it. K equals m minus 14j over 5. A is my answer. Number 17, triangle FGH is similar to triangle JKL, where angle F corresponds to angle J and angles G and K are right angles. Okay, so FGH and angle G is a right angle. So I don't know what the proportions are, but I can get kind of close. So I have FGH and G is a right angle. And I know JKL looks like it. It may be smaller, it may be bigger, I don't know. I'm drawing it smaller. And so JKL and K is a right angle. Now, normally when they say things like triangle FGH is similar to triangle JKL, when you see that written out, that means the corresponding angles, they correspond. And when I say that corresponding angles as they're listed, the corresponding points, those are, showing the proportions here. So F corresponds to J, G corresponds to K, H corresponds to L. That's always the way it's done with similar figures. The order is telling you which point corresponds to which point. I hope I didn't say that too confusingly. So they're making it extra clear by saying angle F corresponds to angle J, But honestly, just from this information, triangle FGH is similar to triangle JKL. The first corresponds to the first, the second to the second, the third to the third. But they've told us F corresponds to J, so we're just going to write it just like that. It's okay. Now, if sine of F equals 308 over 317, what is the sine of J? So sine is talking about the relationship, the ratio of the lengths of sides in right triangles. And if I have two right triangles that are similar, as they are in this case, their proportions are identical. Now this is true, this general statement of similar triangles have identical proportions. That's true of any any two things that are similar. Their sides, corresponding sides, if you're putting them in ratios, they're going to be the same ratios. The difference here, why the right triangle is special with the right angles, is that all those ratios are recorded. They have been determined. They have been observed. They have been recorded. So we know all of them. So here, I would know that if there is a particular angle, whatever angle this is, this degree, then if I took the length of the opposite side, and then I took a ruler and I measured the hypotenuse, and I divided those, no matter how big or small this triangle is, if it's a triangle, it has, like, let's say if this was a, 32 degrees, and then I measured both of those, every single solitary triangle in the world, 32 degrees, the opposite side divided by the hypotenuse is going to have that same ratio, and that is sine. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So again, same angles are going to have the same sine value no matter what size that triangle is. So they're telling us the sine of F, again, I don't know what F is, but it doesn't matter because I know F and J are the same angle. And if the sine of F is 308 over 317, every other angle that has the same measure as F is going to have that same sine. So there is no calculation required here. As soon as you know that F and J are the same angle, which they tell us right here, that angle F corresponds to angle J, you know the sine of these two angles is the same. So it is just B, again, 308 over 317. They may do something more unusual. They may go, oh, well, then what's the sine of L, or what's the sine, that is a possibility. Again, that's going to be, and I'm going to put links down below to videos on sine, cosine, and tangent if you're wanting to expand your knowledge and, and learn some more about those different types of problems that where they're putting in those different trigonometric identities is the term for that. But in this particular problem, they're telling you the sine of F, and they're wanting to know what's the sine of J. It would have been the exact same situation if this had been cosine of F is blah, blah, blah. And then what is the cosine of J? They're the same angle. Their identities, trigonometric identities, are the same. 308 over 317. That's B. Number 18. The product of two positive integers is 546. If the first integer is 11 greater than twice the second integer, what is the smaller of the two integers? Try saying integers 3 times in a row, 4 times. Oh. Right. We need to start setting up some equations to show the relationship between these two positive integers. So I'm going to call them, let's say, A and B. So I have two positive integers. The product of them is 546. Product means multiplying. So A times B equals 546. The next line says, if the first integer, there's my first integer, is, when they're giving you equations in word form, is 99% of the time, I can't think of an exception off the top of my head, is where the equal sign go. The first integer is A equals. What is it? What is it equal to? It is 11 greater. So 11 greater means adding 11. 11 greater than twice the second integer. So 2 times that second integer plus 11 will give me the first integer. Well, now I have a system of equations. A times B equals 546 and A equals 2B plus 11. Now I can use substitution to try to solve this. So I'm using substitution because I already have A is equal to this. So if A is equal to 2B plus 11, I can plug 2B plus 11 up here in for A. So that's what I'm going to do. So I have 2B plus 11 times B equals 546. And then I'm going to distribute this. B times 2B is 2B squared. B times 11 is 11B. And then I get 546. And now when I have a quadratic, and that's what I have because I have this B squared, if I'm wanting to solve, I need it to be equal to 0. So I need to get this 546 over on the other side. So I'm going to subtract 546 from both sides. I can't write. There we go. And I'm going to get 2B squared plus 11B minus 546 equals 0. Now, once you have this equation, there's a couple ways you can solve it. Like I said, I mean, you can factor it. SAT is a timed test. And so I want to do the thing that is the fastest. How can I get this answer the most quickly? And that does vary from person to person. I'm good at factoring, but I immediately saw this and went, I think either quadratic formula or graphing is going to be faster. I'm going to try graphing. So I went to Desmos and I typed this in where I have my equals 2B squared plus 11B minus 546. And it's zoomed in here. It is a parabola with the vertex way down below. But as you can see, there are 2 points where it crosses the x-axis. That's what you're looking for. Those are the solutions to this. Now, notice when it said the product of 2 positive integers, because B could be either one of these. Well, could it? Because here's my 0. Yep, there we go. There's 0. So this number over here is negative. This is the only positive one. So I need to zoom in. And here's my screen grab of when I zoomed in. And just so you can really see 2 reasons why this is not the right one that we want. That is not an integer. An integer is a whole number, you say, in that it is, it doesn't have a fraction, it doesn't have a decimal after it. It differs from whole numbers. I have to go double check this. I admit I do get these confused. I believe we're talking whole numbers does not include 0. I have to double check on that one. But integers is, -5, -5 million, 0, 22, 150. It's all those no fractions, no decimals. Yeah. And so this is not an integer and it is not positive. So I know that's not my B. This, however, yes, that is a positive integer. There is my B. My B is 14. Now that I have my B of 14, I can go back to here and say A times B equals 546. All right, so just divide. 546 divided by 14 gives me 39. So my 2 numbers are 14 and 39. They want the smaller of those. That would be 14, which is B. And you can double check. It's not a bad idea to, if you want to put 14 in here, just double check if that also works. 2 times 14 is 28, plus 11 is 39. And frankly, you could have done it that way too. You could have plugged in your 14 here for that B and gotten 39 as well. Both ways work. It's fine. Number 19. Y is less than or equal to x plus 7, and y is greater than or equal to negative 2x minus 1. Which point x and y is a solution to the given system of inequalities in the xy plane? Whenever you have a system of inequalities, you're going to end up with something that looks like it's either going to be, it could be a straight line, it also could be a dotted line. The difference is right here in the symbol. When it's less than or equal to or greater than or equal to, it's going to be straight, solid lines. When it is greater than or less than or greater than, it's going to be dashed or dotted lines because it's showing that line is not part of it. It is not equal to as well. The equal to part is the line. So when you do a dashed line, it's showing the line is not part of the solution. It's also going to include shading. So if I have something like, let's say I have this dashed line, something like this, it's also going to be shaded on either one side or the other. And that shading shows you all the possible solutions that fit that inequality. All right, so I'm going to cover it now. There's two ways, I should say, before we get into this. There's two ways you can do this. You can type both of these into Desmos and see the shaded area that comes back and then see which of these points goes into that. You absolutely can do that. I am going to show you how to shade this on your own. Once you know how to shade it on your own, you can do a sort of a rough, quick sketch of this and figure this out. Personally, I think it's a little faster than doing it in Desmos. And, you know, it's the SAT. We want you to do things as quickly as possible to give you the most time so you're not left getting questions wrong because you ran out of time. We don't want that. So once I show you this method, it will be up to you which one you want to use. Both are going to give you the right answer. So again, of course, you can just type both of these into Desmos, and you're going to get 2 lines. I'm not drawing this to scale. I'm just drawing 2 lines here. And you're going to be looking for, when you have these kind of problems, you're going to see 2 shaded areas. And then the solution is the place where they overlap. You're going to look for a point that's in that overlapping area. So that's the idea that we're going to do. Now let's get a little more precise here. So first, y is less than or equal to x plus 7. We're going to graph this just like a regular line at first, and then we're going to deal with the shading. So x plus 7. This 7, we're doing things in that y equals mx plus b format. B is the y-intercept, m is the slope. So here, 7 is my y-intercept. 1, 2, 3, 4, 5, 6, 7. And my slope is 1. So up 1, over 1, down 1, over 1. So it's kind of, that's not too bad. That's well, maybe not. Trying to give you a decent, there we go. So there's a decent line. Okay. And if you're just sketching this on a paper, you're still going to get this right answer. And if you're doing it like not to scale, but it's going to give you enough of an idea here, because that's what I did. I always take these tests myself before I try to explain them to others. And I did a quick little sketch, like, boom, there we go. So it doesn't have to be this perfectly drawn to scale. I'm just trying to make it very clear so everyone can see here. Okay, so there's my line. Now I need to know where to shade. Do I shade on this side or do I shade on that side? What I do is I pick a test point. 0, 0, if it is not on the line, is a great test point. You're going to plug 0 in for the x, 0 in for the y, and see, is it true? So there you would get 0 is less than or equal to 0 plus 7. 0 plus 7 is 7. Is 0 less than 7? Yes, it is. Shade this side. So that's my shaded area for that one. Now my other one, y is greater than or equal to negative 2x minus 1. Using our same mx plus b, negative 1 is my x-intercept. Negative 2 means it goes down 2, then to the right 1. There's my, why is this thing? It doesn't like me when I draw dots. I don't know why this whiteboard doesn't like it when you draw dots, but it doesn't. It's a glitch. Okay, so there's my little negative 2 slope. Goes down 2 to the right 1. That's that negative 2. Rise over run, negative 2 over 1. Okay, now where do I shade for this one? I'm going to use that same thing. I'm going to plug in 0, 0 because 0, 0 is not on that line. So 0 is greater than or equal to, again, using that original equation, negative 2 times 0 minus 1. Negative 2 times 0 is 0. And then we have that minus 1. Is 0 greater than or equal to minus 1? Yes, it is. So we shade the part of the graph where 0, 0 is. If I had got a statement that was not true, I shade where it isn't. But because it's true, I shade where it is. So it's over here. And if you plug it into Desmos, this is what you're going to get. It's going to look like this. Now, I know as I'm saying this, some of you are probably saying like, that really wasn't that fast. If you know these concepts really well, this can be the faster way. If this isn't something that you have a lot of experience with, I can't quite get those zeros here. I'm just going to leave them. If this isn't something you have a lot of experience with and you don't think that you can do this quickly, by all means, just, put it into Desmos. The goal is we want you to have this concept that it has to be in this double shaded area, the area where they overlap, that is my winner. That is my place I need to look for. It's in this double shaded area. That's the key takeaway. However you decide or figure out where this double shaded area is, either by doing a quick little sketch and going like, okay, it's going to be right there, or putting in Desmos, whatever works best for you is the way you should use. But this is the knowledge right here, that it's the overlapping area, the double shaded, and that one of these points has to be in that area for it to be an answer, to be a solution. So let's look at each one of these points one by one. First, we have -14, 0. So -14 heading out this way, -14, no. As soon as I head past this like negative half, it's out of the black area here. It's out of this double shaded. It's not an answer. It may be in the green. It's not. But just if I did a quick sketch of this, I'm saying if I didn't draw it to scale, if I just did a very quick sketch, then I still would be able to see, like, no, it might be in the green, it might be out here, but it's definitely not in this black. I don't need to do any further checking, even if it's a quick doodle. So A is out. Then we have 0, -14. So 0, -14. Nope, anything below -1 is out. I know that's where the y-intercept is. Nope, that one is out. Then I have 0, 14. That's going to be way up here. Nope, anything above 7 up here on the y-axis is out, because that's that y-intercept there. So that one is done. Then 14, 0, like, yes, out here, this is definitely going to be, as this expands and gets bigger and bigger, 14, 0, it's definitely going to be in that shaded area. So again, your mileage may vary as to which of these is easier. Please just use what makes more sense. But I want the big takeaway to be, you want it to be in the area of overlap in those two inequalities. That's where your solution is going to lie. Number 20, the square root of x minus 2 squared equals the square root of 3x plus 4. What is the smallest solution to the given equation? This can be solved either mathematically or by graphing. Both work. Again, it's just up to you which you're more comfortable with. I'm going to show you both ways. So mathematically, if I have square root of x minus 2 squared equals square root of 3x plus 34, to undo those square roots, I need to square both sides. That just gets rid of the square root. So then on the left, I will have x minus 2 squared. And on the right, I have 3x plus 34. Now I want to expand this x minus 2 squared. And you can do that one of two ways. You can write it out x minus 2, x minus 2. And then you can do FOIL. You multiply the first, outside, inside, last, and combine. Or if you know there's a pattern for squares, that if you have something that's squared, and this would be considered our A, and this would be our B, what you're going to get every time is A squared plus 2 times A times B plus B squared. This is the shortcut. If you memorize that pattern, you can do this very quickly. You don't have to go through FOIL. But either way that you choose to do it, you're going to get x squared minus 4x plus 4 on the left, and then we have 3x plus 34 on the right. I need to get those over here so that it will be equal to 0, and then I can start solving it. So I'm going to get rid of the 3x first by subtracting 3x on both sides. That gives me x squared minus 7x plus 4, and then I still have that 34 on the right. So I'm going to subtract 34 from both sides, and I get x squared minus 7x minus, wow, I write 7, 4. Sorry. Minus 7x minus 30 equals 0. So now x squared minus 7x minus 30 equals 0. Now some people, if you get to this point, you may decide, right now to put this into Desmos. And what you're going to be looking for, because this is a parabola, you're going to be looking for, wherever it is, we don't know yet, Wherever it ends up being, you're going to look for the 2 points where it crosses the x-axis. Those are going to be your solutions. And that's totally fine if you want to do that. Frankly, I think that's a nice hybrid because this up here, if you type all this, or there's our original, if you type that into Desmos, it's really easy to type that in incorrectly. If you're a Desmos master, you're great at that, you're really accurate, go for it. If that's the way you want to do it, it's fine. Just be careful. Be careful. This one I think is a little easier to type in without mistakes. And the reason I'm saying that this one is you don't have those multiple choices. We don't have that safety net of them kind of limiting your choices. So if you get something that's wildly off, you may not realize that you got it wildly off if there was a typo in the original thing. Okay, so you can put this into Desmos. You can also just use quadratic formula, or you can factor it. I'm going to show you factoring just because I like factoring. So that's the way I would choose to do it. It's the way I did choose to do it when I was taking this right before I always take it first before I go through these videos. So here we have negative 30, and we're trying to figure out what numbers would multiply to negative 30, but add to negative 7. So what are my factors? And let me rewrite that. I did not write that correctly. Shame on me. All right, what are my factors of negative 30? So I'm going to write just the factors for 30 first, and I'm going to write them each twice. So I have 1 times 30, I have 5 times 6, and I have 3 times 10. I'm going to write them each twice so I can put the alternating negatives. And there's my pairs. Negative 1 plus 30 is 29. Nope, that's not it. 1 plus negative 30, negative 29. Nope. Negative 5 plus 6, 1. Nope. 5, negative 6, negative 1. Nope. Negative 3 and 10, 7. Ooh, close. 3 and negative 10, negative 7. Ding, ding, ding. All right, so 3 and negative 10. There we go. So that's going to be x plus 3 times x minus 10 equals 0. When we separate each one of those, we have x plus 3 equals 0 and x minus 10 equals 0. So x plus 3, we need to subtract 3 from both sides, and we get that x equals negative 3. And over here, we're going to add 10 to both sides, and we get that x equals 10. And the question is, what is the smallest solution to the given equation? That is negative 3. Now, if you were to put this initial equation into Desmos very, very carefully, this is what you're going to get. Okay, and see, this is what I'm talking about. So make sure that that squared is under the square root, that all of this is under the square root. It's just easy to make a mistake. I've seen it happen to a lot of students. We don't want that to happen. We're just like, hey, this is quick and fast. And then, no, we don't want that to happen. So this is the graph you're going to get. And as you can see, we're looking for the 2 points where it crosses the x-axis. They are negative 3 and 10, those same answers that we got. Negative 3 is the smaller of the two, so that's my answer. And it's just up to you what you want to do, what you're the most comfortable with, and what you can do quickly and accurately. Those are the 2 keys. Number 21. The regular price of a shirt at a store is $11.70. The sale price of the shirt is 80% less than the regular price, and the sale price is 30% greater than the store's cost for the shirt. What was the store's cost in dollars for the shirt? Now, okay, so here's the thing. With percentages, there's usually more than one way to look at it. So I'm going to present to you the way that when I looked at this problem, it makes the most sense to me. But no, if you're thinking like, well, couldn't you do it if you're going up, going down? There are other ways to approach this. So when I look at this and I see that the sale price is 80% less, we're starting at $11.70, and this is the regular price. The sale price says here is 80% less than that. So I go, okay, if it's 80% less, the full amount is 100%. The sale amount is 80% less. So I want to know what 20% of that regular price is, and then I'll know my sale price. Again, are there other ways you can approach this or look at this? It's going to be the same numbers, 80, 20. The same numbers are going to be in there, but yes, you can come at it a different angle. It's all the same. As long as you're getting to your answer, your sale price is going to be 20% of the regular price. So to get this, I am going to do 1170 times 20%, which is the same as 0.2. The other, I think, most common way to do this, someone might go, well, if it's 80% off, let me find 80% of 1170 and then subtract that from 1170. That also works. They are the same. Okay, so 1170 times 0.2 is going to be $2.34. That is my sale price. Okay, our last part. The sale price is 30% greater than the store's cost for the shirt. Okay, so now I have the store's cost for the shirt. It says the sale price is 30% greater than that. So I'm going to call the store's price X. So 30% more than X is the sale price. So how would I represent that? If the store price, is the absolute, it's the full amount, 100% of the store's price, and then it's 30% greater than that, then the sales price must be 130% of the store's price. So I'm going to multiply this store's price by 1.3 because that's 130%. And that is going to give me the sale price of $2.34. So now I have my little algebra equation that 1.3 times x, and again, remember, I'm using x to represent the store's cost, what our ultimate goal is here. 1.3 times x equals $2.34. Now to undo this, x is being multiplied by 1.3. I need to divide both sides by 1.3. And when you divide $2.34 by 1.3, you get that x is equal to 1.8. So $1.80, the store's cost in dollars is $1.80, 1.80, or 1.8. And that is our final answer. Number 22, a sample of oak has a density of 807 kilograms per cubic meter. The sample, I want to write that down, okay, 807 kilograms per 1 cubic meter. Okay, that's my ratio. You can also write it as kilograms per meter cubed. You can write it like that too. For this kind of thing, I prefer writing it like this so we can get that nice little ratio going. All right, the sample is in the shape of a cube. Okay, so we got this cubic sample of oak. And each edge has a length of 0.90 meters, okay? To the nearest whole number, what is the mass in kilograms of this sample? Well, I know that in every 1 meter cubed, there are 807 kilograms of oak. So I need to figure out how many cubic meters there are here. Cubic meter is the volume. So to find the volume, I'm going to multiply the length times the width times the height. So 0.9 times 0.9 times 0.9. If I'm not mistaken, that's 0.729, but I'm going to double check that in a calculator really quickly. It is. Okay, 0.729. And because each of these are meters, this is 0.729 meters cubed. Now I can set up a proportion here. So I have the original 807 kilograms to every 1 meter cubed. And now on the other side, I've got 0.729 meters cubed. And I'm going to erase this so I have a little more room here. And they're asking us, I just want to double check what units they're asking for. And it says to the nearest whole number, what is the mass in kilograms of this sample? Okay, so they want to know kilograms. This is our unknown, our X. Now this is very critical with these sort of word problems. Always double check that your working units are all the same, because they may throw in some conversion. Like if they had asked for it in grams, I would want to, convert from grams to kilograms, things like that. But here we have kilograms on top, meter cubed on the bottom. Over here I have kilograms on top, meter cubed on the bottom. So no conversion is necessary. These ratios are direct, connected to each other. They're fine. So I can cross multiply these numbers and solve for x. So on top left to bottom right, I have 807 times 0.729. And that gives me 588.3. And on this way, I have 1 times x. That's just x. And there we go. I have my answer. 588.3 kilograms. And they want to know to the nearest whole number. So that would round to 588. And there it is. A is my answer. Number 23. For x is greater than 0, the function f is defined as follows. F of x equals 201% of x. Which of the following could describe this function? Okay, this one, it's pretty straightforward, but I also think it's a little sneaky. Because there's just, it's just sneaky to me. It just feels a little sneaky, and I'll show you why in a second. All right, first, when we're talking about decreasing exponential, decreasing linear, increasing exponential, increasing linear, we're really talking about, you can think of this in terms of shape. So like a decreasing exponential, it's going to look something like this. That as we go to the right, it is getting smaller and smaller and smaller. It's getting closer and closer and closer to 0, or to its line there. In this case is 0, but it's never crossing it. It's just getting smaller and smaller and smaller and smaller. That would be a decreasing exponential. Decreasing linear is a straight line. That is a negative slope. That is, it's going down when we're going left to right. It's going down. Increasing exponential is going to be one that's going up. And as we go left to right, it is increasing. All of these decreasing, increasing are based on, like in English, how we read from left to right. They're all talking about increasing, decreasing in the same way. Increasing linear is a line that when we go left to right is going up. Even if it's ever so slightly, it's still going up. So they want to know this function, which one of those models is it closest to? So f of x equals 201% of x. Now, the reason I think this is a little tricky is because when we think about percentages come up a lot when we're talking about interest and compounding interest and things growing. Like if you have a bank account that grows at we'll say, amazing bank account, this would be at 5% every year. And you're like, that's exponential growth. Like you're getting 5% on 5% on 5%. So I think it's very common or very easy to look at this and go, it's a percentage of this, of X, and percents, increase over time. That's how people make money on interest. So it must be an exponential growth. It's increasing exponentially. So it's an increasing exponential. I'm done, moving on. That's not what this is. I think it's very easy to look at it that way, but unfortunately, that's not the right way to look at it. So f of x is 201% of x. If I said, I want to know, if I just had a number, let's say 5, and I said, I want to know what is 125% of 5, you multiply 5 by 125%. Anytime you're saying what is the percent of a number, you multiply that number by the percent, always. If I want to say what is 72% of 16, you multiply that, 72% times 16. So 201% of x, you're going to multiply 201% times x. 201% can also be represented as 2.01 times x. So this says the function f of x is equal to 201% of x. That, my friends, is just a line. It's a line with a slope of 2.01. So it's going up about like that. and there's no y-intercept on the end, because we're in the format y equals mx plus b, where m is the slope and b is the y-intercept, and there's no y-intercept there. So it's going through 0, 0, and it just has a slope of slightly over 2. So that is a line. It is a linear, and as we go left to right, it is going up. So it is an increasing linear function. 24. Okay, this one. I honestly think there's a shortcut here based on their answers. I'm going to show you the right way to do it, and then I'm going to show you the shortcut that I saw. The reason I'm going to do it in that order is because you cannot count on this shortcut being here in the final answer. We just can't. So we need to know the right way to do this problem. So that one first, then the shortcut. The rational function f is defined by an equation in the form f of x equals a over x plus b, where a and b are constants. The partial graph of y equals f of x is shown. If g of x equals f of x plus 4, which equation could define the function g? We need to figure out what a and b are. A and b are constants, and we need to figure this out. Why do I know we need to figure this out? Because down here in our answers, there are no a's or b's. It's just numbers. So I need to figure out a and b. Now, if I look at this graph, come on, move down. There we go. I look at this graph, and there are some points that pretty clearly are on this function, like right here at -10, -1. Right here at -7, -2. Right there at -5, -6. I think those 3 points we can say pretty confidently they are on this function. So I'm going to say -10, -1, -7, -2, and -5, -6. Now, if I have two variables, and I'm trying to solve for two variables, you need a minimum of 2 equations. That would be a system of equations. If you have 3 variables, you need a minimum of 3 equations to figure them out. Okay, so 2 variables, we need to come up with 2 different equations. Well, here's what we're starting with. F of x equals a over x plus b. F of x is the output that happens when we plug a number in for x. If we're graphing, f of x is the y. So it's saying here, if I put -10 and I do this math, I'm going to get -1 as my output. If I put -7 in here for x and I do this math, I'm going to get -2 as my output, etc. So what I'm going to do is I'm going to take 2 pairs. I'm just going to pick these 2. It doesn't matter. You can pick any 2 you want. And I'm going to plug each of them into this equation in turn, and then I will have 2 equations. I'll have a system of equations, and that will help me solve for a and b. All right, so first, I'm going to take -7 and -2. I'm going to plug -7 in there. So I have -7 plus b. That's all under a, and that is equal to -2. Then I also have, I'm going to use -5 and -6. I plug -5 in for x, and I'm going to do this in, let's do this in green. Why not? So these 2 separate things here. All right, so -5 plus b on the bottom, a on top, and all this is equal to -6. All right, now I have 2 equations. I am going to get rid of these fractions down here. So first here on the left, to get rid of this fraction, I need to multiply both sides by -7 plus b. So that's what I'm going to do. And I realize now I have done a little bit of a disservice to myself. Let me move this over. Give me some space. There we go. That's better. That's smart. All right, so I'm going to multiply both sides by -7 plus b. I'm trying to write really small and neat here. Okay, on this side, same thing, -7 plus b. I really did not give myself enough room, did I? No, I didn't. On the right-hand side, those cancel out, and I am just left with a. On the left side, I'm going to distribute. -2 times -7 is +14, and -2 times +b is a negative 2b. So now I have 14 minus 2b equals a. And I'm going to slide that over a little bit. Okay. Now over here on this side, same thing. I'm going to scoot this over. Okay. I'm going to do the same thing over here. I need to multiply both sides by this here one. I actually am Southern, so it does come out every now and then. This here fraction, I need to multiply by the denominator on both sides, negative 5 plus b. On the right, that cancels those out, and I am just left with a. On the left, I'm going to distribute here. Negative 6 times negative 5 is positive 30. Negative 6 times b is negative 6b. Okay, now I have something. This is really nice because I have 14 minus 2b is equal to a, and 30 minus 6b is equal to a. So these are equal to each other. They're both equal to a, so they're equal to each other. I can set them equal to each other, and I can solve for b. And from there, I can solve for a. All right, so I'm going to reorder them to put the variables first. Negative 2b plus 14 equals negative 6b plus 30. I am going to, it's becoming very messy, isn't it? Yep. I am going to add 6b to both sides to get the b's over here on the left. So negative 2b plus 6b is 4b. All right. And then I want to get rid of that, get rid of the 14 by subtracting it from both sides. So I'm going to subtract 14 from both sides, and I get 4b is equal to 16. Okay, since b is being multiplied by 4, to undo that, I need to do the opposite, divide by 4. So now I know b is equal to 16 divided by 4, or 4. Yay, I know b is 4. Woohoo. Now I'm going to go up here, and this can be, and actually I'm going to write this right up here. b equals 4. Okay, so if I need to erase anything, that's still there. Okay, now I can use either one of these two equations to solve for a. I'm going to use this one over here. So 14 minus 2 times b equals a. I now know that b is 4. 14 minus 2 times 4 is 8 equals a. 14 minus 8 is 6. A is 6. Yay! All right, now I know a is 6 and b is 4. Cool beans. Okay, I am going to erase all this. I hope everyone got what they needed from that, because we are going to need this space. Okay. All of that just to find out that A was 6 and B was 4. Okay, now let's go back and look at our problem here. It says if g of x is equal to, we're down here at this part. Okay, if g of x is equal to f of x plus 4, which equation could define g? I'm going to rewrite this original equation because we had it as f of x equals a over x plus b. But we know now, that a is 6. And we know that b is 4. So that's the original equation. F of x is 6 over x plus 4. Now, g of x is equal to f of x plus 4. So that means wherever there's an x in this f of x, we're going to plug in x plus 4. Okay, so there's one x. So for that x, I'm going to plug in x plus 4. Okay, and so that will give me 6 over, plug in that x plus 4. Wherever there's an x, there's only one x, plus 4. Now, because these are all just being added, I can now remove those parentheses. X plus 4, I can combine those, and now it is x plus 8. 6 over x plus 8, that is what g of x is, and that is c. G of x is 6 over x plus 8. Okay, I know that's a long road. It is. It's probably the longest problem in here, definitely one of the longest problems in here. Here is the shortcut, which I'm going to show you because if you come across something like this, I mean, it's not a bad idea to look for this kind of thing, but don't count on it. Know how to do what I just showed you, because that will take you through no matter what. All right. So here's the thing I noticed when I looked at this. I know that f of x is equal to a over x plus b. And they're telling me if g of x is f of x plus 4. So I know x plus 4 is going to go right there, right? So I could rewrite that original f of x as it's a over, what g of x, is going to be is a over, and then there's going to be x plus 4 in for that x plus b. That's what g of x is going to be. They've told us that. So the a didn't change, right? A stayed the same. This little thing on the bottom changed. Look at their answers down here. I'll zoom in so you can really see. We've got a 6, got a 6, got a 6, and have a 6 times an x plus 4. So my sort of assumption, my logical assumption at that point is, the a on top, nothing's changing. The only thing that's changing is on the bottom. So this one with the x plus 4 on the top, that seems ridiculous because I already know g of x is just going to be a over x plus 4 plus b. Now, are there circumstances where you have to simplify and multiply things on top and bottom? Yeah, there is. Doesn't feel like that's just, from my experience with math, it does not feel like that's the case here. So I look and see we've got 6, 6, 6, there's 6 again. My instant thought is, what can a be but 6? That's my assumption at this point. The logical assumption based on the 4 answers that they've given me, that a must be 6. Now I have to prove that. I have to make sure it works. I'm like, okay, if a is 6, I have 3 test points up here. I can plug 6 in for a and then pick any of them. I'm going to put -5 and -6. I'm going to put -5 in for x, and I'm going to put -6 in for b, and solve for b from there. Now, that I jumped a huge portion. I jumped all those steps of plugging these in, creating 2 equations, creating the systems of equations, solving for a. I just jumped fully ahead by just assuming that a is 6. In this case, I was right. And you're going to progress the same way as we did for the rest of the problem. But that was a little shortcut that I realized it's got to be, it has to be, that a would have to be 6 in this scenario. And just as a little, if you were wondering like how you would do this, let me just write it over here. -6 equals 6 over -5 plus b. Same sort of thing, we need to get rid of that, so we're going to multiply by -5 plus b on both sides. Just leaves 6 on the right, then you're going to distribute. -6 times -5 is positive 30. -6 times b is -6b. And then you subtract 30 from both sides. Get -6b. I am going through this pretty quickly. 6 minus 30 is -24. Divide both sides by -6, and b is 4. Yep. And once you know b is 4, then you go over here and you're like, okay, my a is 6, my b is 4. I combine those. There we are back again. 6 over x plus 8 c. Again, I am not telling you that to say that's what you, that's going to work every time, because generally they're more subtle in their answers, and they give you a variety of things that you can come up with as answers, so that they're not just giving the game away by using 6 in every single answer. But I'm just pointing this out. Again, keep your eye out for clues in these answers, especially for these trickier problems. There often are clues in the answers that can cut down on the time you need to spend. But that first method that I showed you, even if they don't give you that sort of clue in the answer, it will still work. But that is a really long problem. It's just is. It's going to take you a minute. All right, 25. Which expression is equivalent? Y plus 12 over x minus 8 plus y times x minus 8 over x squared y minus 8xy. I can't talk. All right, anytime you want to combine two fractions, they have to have the same denominator. It doesn't matter if I'm adding 1/2 and 1/4, or if I'm adding 1 over 2x plus 1 over 4y. They have to have the same denominator, then I can add them. So let's look at these two. First, I have y plus 12 over x minus y. And then I have y times x minus 8 over x squared y minus 8xy. Now, I see an 8 here and an 8 here, and there's an x here and an x here. Is there anything I could multiply this by to get to that? Well, what if we took out a greatest common factor over here? Over here, I've got two x's. You can always take out the smaller if the variables are in both terms. So there's that single x. I can take that out. It would leave behind an x in the first term and a 1 in the second. Then I've got a y in both terms. Okay, so I can take a y out. So the y disappears from that first term, and it disappears from the second one. So that takes care of the variables. And then we've got that 8. So 1 times 8, or just 8. So xy times x minus 8. I'm covering up the 8 there. There we go. So if I multiply this x minus 8 times xy, I will get x squared y minus 8xy. Now, anytime you're multiplying a fraction, you're multiplying the denominator by something, you have to multiply the numerator by that same thing, because you're essentially multiplying by 1. A number over itself, not including 0, is equal to 1. So x times y over x times y is 1. I can multiply this whole thing by 1 and not change it. Okay, so I'm going to do that first. Let me distribute here. Xy times y is xy squared, and xy times 12 is 12xy. Then on the bottom here, I have the denominator I was looking for, x squared y minus 8xy. Woohoo! Now up here, I'm going to distribute this. X times y is xy. Y times negative 8 is negative 8y. That's all over x squared y minus 8xy. Now I can combine because they have the same denominator. So I'm going to have xy squared plus 12xy plus xy minus 8y. All over x squared y minus 8xy. There we go. Okay, now I'm looking up here. Can I simplify any further? Are there any that have identical variables? Right here in the middle, I do. I have 12 xy's and one more xy's. So together that is 13 xy's. So I can combine those, 13 xy, and that's it. I can't combine any more because that xy squared, xy, y, none of those match. So let's look over at my answers, and I'm looking for x squared plus 13xy minus 8y over x squared y minus 8xy, and lo and behold, there it is. C is my answer. Number 26, poll results. Angel Cruz 483, Terry Smith 320. The table shows the results of a poll. A total of 803 voters selected at random were asked which candidate they would vote for in the upcoming election. According to the poll, if 6,424 people vote in the election, by how many votes would Angel Cruz be expected to win? Okay, there's two different ways that you can go about this. Two different paths that I see, just which makes the most sense to you. The key is in this question, it's not how many votes would Angel Cruz get. It's by how many votes would he be expected to win. And I guarantee you down here in those answers is how many votes did he get? Because they want you to think that. It's not. It's by how many did he win. So let's say if Angel got 100 votes and the other guy got 75, he won by 25 votes. That's the number they're looking for, the difference between the two. Okay, so when we're talking about polls, we're using these subsets of polls to predict what the bigger groups are going to do. So we're always using these ratios of part to whole and setting up proportions. So Angel Cruz's votes, he got 483 out of a total of 803 voters. Now, if I want to know just how many votes Angel Cruz could be expected to get, a good estimate, I'm going to use this part here where it says 6,424 people are voting and say, okay, so the bigger whole would be 6,424, and I'm going to figure out how many of those votes would go to Angel. Okay, so this is the first method. You can do this. You can solve for the votes that Angel gets. You're going to do this by cross multiplying. And 483 times 6,424, which I can do mental math, but not that I can't, is going to give me 3,102,792. And cross multiplying the other way is 803x. Then I need to divide both sides by 803 to undo that. And that will give me 3,864 votes for Angel. And what did I tell you right there? They put it there as an answer. So there's my votes for Angel. Now I would need to find the predicted votes for Terry Smith and find the difference. So the same proportion that I did up here and do it once more for Terry Smith. So his votes, 320 out of 803 voters in this poll. And the prediction is he's going to get, let's call his Y. Y votes out of 6,424 on the day. Then we do the exact same thing we just did. We would cross multiply 320 times 6,424 gives me 2,055,680. And the other way multiplying is 803y. And so when I divide 2,055,680 by 803, since we're dividing both sides by 803, then y is equal to 2,560. Right, so Angel is predicting to get 3,864. Terry is predicting to get 2,560. And when I subtract those, I am going to get 1,304. So I'm estimating that Angel is going to win by 1,304 votes, which is B. There is one other way to do this. I think it's a little faster, but this way right here, I think probably makes more sense to people. But just whatever works best for you. Neither is right or, neither is wrong. Excuse me, both are right. So the other way you can do this, which is like one sort of less step, is you don't have to find what votes does Angel get, then what votes would Terry get, and then subtract them. You can find in this original poll, how much did he win by? And then use that to set up your proportion and just do that one proportion. So in that first one, Angel got 483 and Terry Smith got 320. So Angel in that poll won by 163 votes. So that ratio, this is the number of votes he won by, to when there were 803 voters. So we're going to set up the same sort of thing because this is how many he won by, and this is the number of voters. And as long as I do those same two numbers, those same two things, how much you're winning by and voters, the proportion is still true. So here I've got 6,424 voters, and I'm just doing this to signify what they are. These are not variables. I'm just doing that as a reminder of what we're dealing with. And I want to know how much does he win by. Same sort of thing. We would cross multiply, and then 6,424 times 163 is 1,047,112. Then 803 times x is 803x. Then I would divide both sides by 803. And x is equal to, once again, 1,304. So here you only have to do one proportion, one cross multiply, one divide. So you're cutting a whole one of those out, which on the SAT, when every second counts, that could be very helpful. Again, if that didn't make sense to you, if you want to do it the sort of more straightforward way, it's totally fine. We want you to do what makes sense and it will help you get the right answer. Number 27, last problem, yay! In this section anyway, this module, the graph of x squared plus x plus y squared plus y equals 199 halves in the xy plane. It is a circle. I read that wrong, but you know what I meant. What is the length of the circle's radius? Right, the formula for a circle looks like this. X minus h squared plus y minus k squared equals r squared. So we have these two squares, these two perfect squares, and h and k are the coordinates of the center of the circle. So let's say, and r is the radius. So if this was x minus 2 squared plus y plus 3 squared equals 16, I would know this is a circle with a center of, it's always the opposite, because remember this is minus h, but we just want h. So you take the opposite. So negative 2, you take the opposite. Positive 2, positive 3, take the opposite. Negative 3. The center is at 2, negative 3. This is r squared, so I take the square root. The radius of this circle is 4. All circles are going to be in this format. So when you are given something that looks like what they just gave us, which is x squared plus x plus y squared plus y equals 199 halves. That is a pathetic equal sign. 199 halves. And they want it to be the formula of a circle. They need you to get it into that x minus h squared plus y minus k squared equals r squared. It needs to be in that format. So you need to turn each of these into perfect squares. So this is going to be completing the square. This is probably something you did back in Algebra 1. You probably did it for a week or two and didn't like it that much because not many people do. And you thought, I passed the test. I never have to think about this again. Well, blah, ha, ha. Geometry comes back and laughs evilly in your face and says, yes, you do. You have to complete the square. Honestly, completing the square pops up so often. And students are always surprised when it comes back. And they're like, what? It's back again? I know. I'm sorry. It is what it is. And completing the square is it just keeps coming back to bite you. It does. Just going to interject here for a second. I'm guessing some of you are wondering or asking, maybe even saying out loud, why isn't she just putting this in Desmos? That would be so much easier. Just type it in and boom, there's your graph. Here's the reason why I think for this particular problem, this is prone to error. I think it's really easy to make a mistake using Desmos on this. If you can use it and use it accurately and get the right answer, that's great. Awesome, go for it. But I'm not recommending it to everyone because I think it's really easy because this particular circle, it's not centered at the origin. It is centered at, really doesn't like it when you try to do dots. It's centered at negative 0.5, negative 0.5 right there. So everything is slightly off to the left, which means these two dots that it highlights right off when you open it up, the x-intercepts, they do not represent, if you connect them, they don't represent the diameter of the circle. And I think it's really easy for students to think that's the diameter, so I measure the distance between these 2 points, cut it in half, and I've got my radius, and you will not get the right answer. It'll be close, but this is not a multiple choice. It is a write it in, so you will get it wrong. What you would have to do is realize that it's these two little points here that are slightly to the left of the x-axis, right to the left of these other two highlighted points that are the y-intercepts. And those two little points to the left would represent the end of a diameter, and you could find the radius from that. So again, for this particular problem, I am not recommending Desmos as my preferred method to do it. And plus, I just think it's a good idea to know the math that's going on behind it because we don't know what the exact type of problem you're going to get on the day when you take the SAT. And if you get a problem that's like this, where it's maybe not immediately clear through Desmos, like what the answer would be, it's always good to know the math that's going on behind the scenes so you know you can tackle any problem regardless. All right, back to the math. All right, to complete the square, I'm going to put some links in the videos down below that explain a little bit more about why this works, which I think is good to understand the why behind math principles and math rules. Just in this video, I'm just going to tell you the steps, but the explanation as to why the steps work, link down below. So first, if I am completing the square of this, x squared plus x, I'm going to forget about the y squared plus y. I'm going to have to do this again with the y squared plus y. That's another thing. All right, to complete this square, I need to figure out what number can I put here that would turn this into a perfect square of x plus something squared. Okay, if I have a perfect square, it is in the formula a squared plus 2ab plus b squared. So my first a, which is going to be the term here, becomes this. This is going to be 2 times a times b, and this is b squared. So in this case, anytime, first off, okay, I should say, anytime you're completing the square, you want to make sure there's nothing in front of the x. There's no 2, 3, -5, nothing. If there is, you need to divide all the terms that you were given by that number to get rid of it so that it is a 1 in front of the x. We already have a 1 in front of the x, so we're good. The next step is you are going to take whatever number is in front of the x squared. I should have said, I was circling the right thing. I didn't say the right thing. I'm sorry. You're going to take whatever number is in front of the x. In this case, it is an understood or invisible 1. You're going to divide it by 2, and then whatever you get, you're going to square it, and that is the number you're going to put right here. So this is a 1. We're going to divide that by 2, and that gives us 1/2. 1/2 squared is 1/4. That's what goes there. And this number that you get at the point where you divide by 2, that's what goes here. So if this had been say this was a -1, this would be a -1/2, then it would be a -1/2 we'd be putting right there. In this case, it's a +1/2. So there we go. And if you do FOIL and you multiply this out, this is what you're going to get. You're going to get x squared plus x plus 1/4. Okay? So again, those are your steps. You make sure there's no number in front of the x squared. If there is, you divide both of these terms by that number. And I'm trying to think of like with, and be careful with this. I will say to be cautious with this. When I say divide the terms by that number, I need to be clear on this. This whole thing is one big ecosystem up here. So if I have to divide these x squareds to get rid of something, I have to divide all of this by it. We don't have to do that in this one. I don't think they're going to give you something like that on the SAT. It's a little complex. I don't think, I should say not beyond the scope of the SAT. We'll put it that way. I think it's beyond the scope of what they're going to ask you. But just know that for your completing the square journey in the future. So the process you're going to need to know for this is, again, you take that number that's there, invisible 1 in this case, you divide it by 2. Whatever number you get for dividing by 2 goes here. And then you square it to get the number there. Again, if it doesn't make sense why, please watch the video that's down below. All right, so I'm adding 1/4. All right, I'm going to keep going. Now I have this other side, y squared plus y. Now this is, in this case, hey, it's identical to this one over here. I've got a single y squared, I have a single y, single x squared, single x. So you guessed it, it's going to be the same, adding a 1/4 to it, because it's the same thing. There's an invisible number 1 right there. I divide by 2, that gives me 1/2. I square it to get my third term, 1/4. Okay, now this is an equation with an equal sign. Equal signs, everything has to stay balanced. So I added a 1/4 and a 1/4 to turn these into perfect squares. So I need to do the same on the other side. It's getting quite long and I keep zooming out. There we go. So I need to do the same thing over here. I need to add a 1/4 and a 1/4. All right, I'm going to rewrite these as their new perfect square selves. So here we have x plus 1/2 squared. I just like things to be nice and neat here. And then y plus 1/2 squared equals, now over here, 199 over 2 are 199 halves. 1/4 plus 1/4. Now, first off, okay, if I was just adding these two together, I would need to change this denominator. But because I have these two 1/4s that are the same denominator, I'm going to add them first. 1/4 plus 1/4 is 2/4, which can be simplified to 1/2. Hey, now that's nice. Now it's 199 halves plus 1/2. So that 199 plus 1 is 200 halves. 200 divided by 2 is 100. Now this is starting to look like a proper equation, and I'm just going to skip writing that 3 times. I'm only going to write it 2 times total. So it should have been there, but I just got lazy and frankly tired. It's the last question. I'm tired of writing all this stuff on a computer screen. All right, there is my equation of a circle. Woohoo! X plus 1/2 squared in standard form plus y plus 1/2 squared equals 100. So that 100 is, as we mentioned up here, the radius squared. So 100 is that radius squared. What is the square root of 100? That is 10. My radius is 10, and that was the question. What is the length of the circle's radius? 10 is my answer. Congratulations. You have made it to the end of this section. Hey guys, if this was helpful or useful in any way, please let YouTube know so I can keep helping you and others like you. Comment, like, share, subscribe, you know the drill. Also, if you're interested in practical or fun math-related items like this math clock or this hopefully humorous t-shirt, click on the links down below to check out my Spreadshop and Etsy stores. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.